This is session 2 of the parabola. From session 1, we dealt with the following. For f of x equals to a all into x minus p all squared plus q, where the axis of symmetry is p and the minimum or maximum value is q. Axis of symmetry and maximum or minimum value will give you the turning point of the graph, which is TP, where x is represented by p and y is represented by q. Remember, the axis of symmetry is not influenced by the a value or the degree, the exponent. Whatever value you have here as the degree or exponent or the a value, the axis of symmetry concentrate with the values within the bracket. The a and q effects. This is from the previous session. For a and q having the same sign was illustrated in the previous session. We have dealt with this extensively in session 1. Please refer to session 1 to see what I'm talking about. But I'm going to recap on that before we proceed with our session 2. For a and q having the same sign from session 1, roots are non-real. It means x squared is lesser than 0. When you see non-real or x squared lesser than 0, know that your graph won't touch or intercept the x-axis. If a and q are positive, it opens upward and gives you the minimum value, and they are both positive, they should be above the x-axis. And if a and q are both negative, it opens downward and gives you the maximum q value. They are both negative, below the x-axis for negative, above the x-axis for positive. Today's session is about a and q having opposite signs. If a and q have opposite signs, the roots are real and unequal. It means it cuts the x-axis at two unequal points, two different unequal points. x1 is not equals to x2. If a is positive and q is negative, q is the minimum value and below the x-axis. If a is positive, greater than 0, q is the minimum value. Therefore, x1 is not equals to x2. Two unequal roots. Should x1 not be equals to x2, the roots are real and unequal. Two unequal real roots if a value and q value have opposite signs. For a lesser than 0, which is negative, and q greater than 0 positive, Q is the maximum value and above the x-axis. For A lesser than 0 negative, Q is the minimum value. A negative, it opens downward, and x1 is not equals to x2. Therefore, there will be two unequal roots. Guys, let's go back and look at this again. For real unequal roots, x1 is not equals to x2. x1 not equals to x2 for graph A greater than 0 opening upwards. x1 is not equals to x2 for graph A value opening downwards. Roots are real and unequal. We have two real roots. Let's consider the graph of f. The graph of f, which is y equals to x squared minus 4, and of g, which is equals to minus x squared plus 4. F is y equals to ax squared minus 4. Y equals to a squared minus 4, meaning that a value is positive and q value is negative. They have opposite signs. It means the roots are real and unequal. For roots, x-intercept is equals to 0. Therefore, x squared minus 4 will be equals to 0. Instead of y, we have replaced y with 0 because we are cutting the x-axis. On the x-axis, y is 0. Then we have x squared equals to 4. Therefore, if x squared is greater than 0, we know that the roots are real and equal. In this case, x squared is greater than 4. Therefore, we will have real and equal roots. Therefore, x equals to plus minus square root of 4. It means x is minus 2 or x is 2. x1, x2, 2 unequal real roots. Therefore, the axis of symmetry at this stage, it is still the y-axis where x is 0 and the minimum value is negative 4. Therefore, the turning point is 0 and 4. The y-intercept will be negative 4. If the axis of symmetry is on the y-axis or lying on the y-axis, the minimum value and the y-intercept will share the same spot. Let's go to G. The graph of G. What do we have here? G is y equals to negative x squared plus 4, where a is negative 1 and q is positive 4. They both have opposite signs. Roots, the x-intercept, y will be 0. It's minus x squared plus 4, which means x squared is equals to 4. Look, x squared is greater than 0. Therefore, the roots are real and equal. It means x1 is not equals to x2. Therefore, x is equals to negative 2 or x equals to 2. Axis of symmetry, it's still 0, and we have the maximum value of 4. The turning point will be it will be 0 and positive 4. The roots will be real and equal. That is, x squared is greater than 0. Then we go for q equals to 0. But before we go there, it is important Guys, it's very, very critical to comprehend this. These sessions are not about knowing how to get the answers right. It's knowing what you need to do and how to do it, how to avoid certain pitfalls when you are in the exam room. We are preparing you to move faster and quicker in that exam room. Marks are maximum when you are faster and quicker and efficient. This is about efficiency. Memorize this because we are still coming with a lot of content to explain and dismantle this. Now, let's go for Q equals to 0, which means minimum or maximum. If Q is 0, the roots are real and equal. If the roots are real and equal, x1 will be equals to x2. Therefore, x squared will be equal to 0. Now, for a greater than 0, positive, what does this mean? It means that axis of symmetry will be 0, minimum value would be 0. Let us look at what we're talking about. The roots are real and equal. x1 is 0, x2 is 0. They are equal. The same with this one. If it opens downwards, it becomes negative. Axis of symmetry, the same as here. Maximum value, the same as here. In this case, it's minimum or maximum. Thanks for watching. Please like the video, click the button and subscribe. See you in session 3.